Hi, welcome back to Math 520 and welcome to week 8 of the semester. This week we're going to move on to sections 5b and 5c of Axler, finishing out chapter 5. Now in these two sections we're going to focus on some fundamental problems having to do with linear maps and make some very important definitions about them and prove some important theorems. Arguably, the most important theorem we're going to have is that if we have a linear operator on a finite dimensional complex vector space, it must have at least one eigenvalue. So that's going to be one of the theorems. That's the first theorem that's proved in section 5b. And then we're going to open up to a class of problems. And the class of problems have to do with representing linear maps by matrices. And if you remember, when we looked at linear maps, let's say between a vector space V and W, when we made a matrix for that linear map, we chose a basis for V and a basis for W, and from those choices we were able to get a matrix. But now, if we focus on linear operators, that's a linear map from V to itself. In that case, we're only going to give ourselves the possibility of choosing a basis for V. And in that choice, we will have made the choice of a basis for both the domain and the codomain. And in that circumstance, that's going to make the matrices that we get be restricted to not just be anything at all, but instead we're going to have to do some work to understand what they can be for various different choices of bases of V. And in particular, we're going to ask the question, when is there going to be a good choice of a basis in which the matrix is diagonal? When is there a good choice of a basis where maybe we can't get diagonal, but maybe we can get at least upper triangular? So these are going to be what we're going to look at, and it's going to turn out the answer to these questions has a lot to do with eigenvalues and eigenvectors. And we'll take a deeper look at that. And in later weeks, we're going to build on this as we progress in our trip to the spectral theorem for these operators on finite dimensional vector spaces. Okay, let me point out there's an important technical point. This is related to a discussion that we were having on Piazza. But the important technical point is from this point forward, unless I specify otherwise, but from this point forward, we're really going to assume that all of our vector spaces are going to be complex vector spaces. This is not a strong assumption. I'll explain a little bit about that on Tuesday, but it is an important assumption, and we're going to work with that moving forward. Okay, I'm going to remind you now about course mechanics. As always, we have a discussion forum post due on Wednesday. And then, depending on whether you're a graduate student or an undergraduate, you have 2 or 1 responses that are due this coming Sunday. This week, we're going to go back to our written homework assignments, so check out on Blackboard to see the assignments. And as always, I'm going to post the suggested readings and suggested problems and links to the various videos from Axler.